Hi guys, welcome to our channel of Sciences and Mathematics. I'm Ernest. Today we're going to look at one of the concepts in volumetric analysis, and that is the concept of standardization. Now we have looked at the concept of titration for bulk and acid-base titration in some of our videos, and we have already talked about the aspect of the reacting mole ratios and the stoichiometric of chemical equations. Now in this case, the process of standardization is a titiometric process that entails finding the concentration of a known solution from the reacting mole ratios and the stoichiometric relationship that we have already discussed. Now for today, we're going to use an example, a simple example, in trying to figure out how we can be able to perform this specific process of standardization. So without further ado, thank you and welcome. So in us trying to find out what this specific process of standardization entails, it is going to be of essence for us to try and connect the relationship between the stoichiometric equation or stoichiometry, which basically will assist us to know the reacting mole ratios or volumes. And therefore from this we're going to find the relationship between the concentrations and the volumes of the reactants and the products which are taking place. Now from this particular illustration, we're going to use one of the examples of the reaction between sodium hydroxide and HCl, which is an acid-base reaction, of course, to try and figure out how we can be able to define this concept of standardization. Now from the definition, basically standardization refers to the determination of a concentration. So this basically is the determination of a concentration of a known solution. Which basically entails the use of another solution whose concentration is known, that we are basically going to refer later to as a standard solution. So this comes from the concept of standardization, whereby the process entails the finding of a concentration of a known solution from the known solution that we have seen, especially from the chemical reaction that we are going to see, which is an acid base that I've mentioned. So in this case, we're going to see that a solution whose concentration is known, which I've referred to as a standard solution, is going to be reacted with another solution whose concentration is unknown, and this will lead to the stoichiometric reaction or relationship that I've already mentioned in this. Now from this stoichiometric relationship, then we're going to use the relationship to try and figure out how we can be able to maybe quantify the concentration of that known solution. So in this process of standardization, we apply the concept of, I've mentioned about the concept of the geometric relationship. And I've talked about the concept of titration, so therefore there is going to be the concept of an endpoint for this reaction, which has to be determined in order to ensure that this is specific reaction between a concentration, a solution whose concentration is known and the one whose concentration is unknown, has come to an endpoint. So therefore, there's usually the use of different indicators to try and figure out which kind of, or maybe at what point as the reaction proceeds is the endpoint. So at that specific point, then therefore we are going to use the stoichiometric relationship that I've mentioned in order to figure out. So as I said, we're going to use the reaction between sodium hydroxide and hydrochloric acid to try and do our example. This basically is referred to as a neutralization reaction, which is an acid-base reaction. And we're going to achieve that by using our sample question. Now I'm going to read the question so that we can be able to extract the information and use it to find out how we can do this process of standardization. Now suppose we have a hydrochloric acid, which is undergoing standardization with 0.1 molar sodium hydroxide. And in this case, the volume of sodium hydroxide that is used in order to fully neutralize the acid is 27 centimeter cubed of sodium hydroxide is required to neutralize 30 centimeter cubed of HCl. And then lastly, we are required to find the concentration of HCl. I've just roughly put this specific question because it's a long one, just extracting the information. So I'm going to read it as a form of guidance. So in this case, this HCl is of a known concentration, and therefore is the one that we're trying to find the concentration. So therefore, hydrochloric acid undergoes standardization with 0.1 molar sodium hydroxide. So basically, we're going to refer to sodium hydroxide as a standard solution because basically its concentration is known given as 0.1 molar. So during the reaction, 27 centimeter cubic of sodium hydroxide of this known solution is required to neutralize 30 centimeter cubed of HCl. So we're required to determine the concentration of HCl from that one. So the first step in us trying to find out this one is to finding the reacting mole ratios. So the steps, the first one is to find the reacting mole ratios for the acid base by trying to balance this equation. So therefore we're going to see that this is a sodium 1 chlorine. So we're going to have this specific chloride 1 H2. So the way this equation is, basically it's balanced. So this is an aqueous solution which is reacting with this one to form an ionic solution plus water. So therefore the acid-base reaction entails a reacting mole ratio of acid to base which is 1 to 1. So therefore from that we can conclude that the number of moles of acid that reacts with a base reacting to the acid is 1 to 1. So from this we can find the number of moles of the known solution which is sodium hydroxide. From the concept that we have been told 0.1 moles are contained in 1,000 centimeter cubed of sodium hydroxide. So basically from the concept of 1 molar. So therefore if 27 centimeter cubed of sodium hydroxide was used, we can give a relationship from this and say 27 centimeter cubed of this specific base will contain how many number of moles. So I'm going to have to do away with basically this part of the board so that we can use it. So from this we're going to give a relationship and start from here and saying this is 0.1 moles times 27 centimeter cubed divided by 1,000 centimeter cubed. So this is going to give us moles which basically are going to be 0.0027 moles of sodium hydroxide in 27 centimeter cubed. Since the mole ratio between the acid and base is 1:1, therefore we can be able to conclude and say therefore this implies that 0.0027 moles of the acid were contained in 30 centimeter cubed. So in us finding the concentration of that specific acid, we're going to use the concept of molarity and say that if 0.0027 are contained in 30 centimeter cubed, for 1 molar it's going to entail 1000 centimeter cubed of HCl. Therefore, giving that relationship, we're going to see that, and still to away with this, we're going to see that the cross multiplication for that is going to give us 27 times 1000 divided by 30, and that basically is going to give us the calculation. So that is going to give us 0.09 molar HCl. So from this we have seen that the reaction between HCl and a base which is sodium hydroxide can be able to give us a stoichiometric relationship whereby the reacting mole ratios are 1 to 1. Now, having been given the concentration of the base and the volume of the base that was used, we can use the relationship between volume and the number of moles in order to find the number of moles of the base that were used, and therefore from this ratio the number of the acid that were used versus the number of the base that was reacting with it. And therefore from this one we can use the relationship for 1 molar in order to find the concentration of the acid that basically was unknown. So therefore, finding the concentration of this specific unknown reactant by use of this procedure and the relationship is the process that we refer to as standardization. So basically that is how we can be able to deal with those specific reagents given the information of one concentration of maybe a solution whose concentration is known, which we have basically referred to as a standard solution. Then therefore we can be able to use the stoichiometric relationship to finding the concentration of another. Now this process entails the concept of standardization that we have done. I hope this is going to assist us in trying to figure out how to calculate other solutions for problems that we may come across, that it basically stems from the concept of volumetric analysis or tachymetric analysis and other questions. So that is it for today, guys. Bye, God bless.